Earth cycles summatives.
You know that Earth orbits the sun, right? And that it takes a full year for our planet to complete its orbit. Earth also rotates like a slightly tilted spinning top. Earth remains tilted in the same direction all year round as we orbit the sun. But that means the sun's light shines differently on Earth at different times of the year. Let's look at Earth when it's winter in the northern hemisphere. Observe how the North Pole tips away from the sun. This means that sunlight strikes the northern hemisphere at a shallow angle for a short period of time. This is why winter weather is generally cool, with short days and long nights. As Earth orbits the sun, we move towards spring in the northern hemisphere. Now Earth is tilted neither toward nor away from the sun, as day and night are about equal in length. As we make our way to the summer months, notice that Earth is still tilted in the same direction, only now on the other side of orbit. The North Pole is tipping toward the sun. Sunlight strikes the northern hemisphere more directly, and the sun stays in the sky for a longer time. Compared to winter, summer days are warmer, and the sun stays in the sky much longer. Notice too that while it's summer in the northern hemisphere, it's winter in the southern hemisphere. Because of Earth's tilt, the seasons are reversed. We observed how Earth's tilt creates the different seasons throughout the year. How does this affect life? Plant life and other photosynthesizers, we call them primary producers, depend on sunlight. They respond to the changes in the seasons. Earth orbiting satellites measure the amount of carbon dioxide absorbed by these primary producers. Bright regions on this map show where they devour the most carbon dioxide, turning.
So, in summary, for our seasons, we have 4 seasons, and the equator divides the northern hemisphere from the southern hemisphere into two equal parts. When the hemisphere is tilted away from the sun, that hemisphere is experiencing winter. When the hemisphere is tilted towards the sun, it's experiencing summer. So in this image, we have the southern hemisphere tilted towards the sun, so they're experiencing summer, where we have longer hours of daylight and increased temperatures. In the northern hemisphere, it's tilted away from the sun, so they're experiencing winter. Winter means shorter hours of daylight and cooler temperatures because the sun's rays are striking the northern hemisphere at indirect angles. The Earth does a counterclockwise revolution around the sun. And our next position we're going to look at is this one here. Here we see the northern hemisphere is tilted towards the sun, so they're experiencing summer, longer hours of daylight, warmer temperatures, and more direct sunlight rays. Down in the southern hemisphere, just the opposite. They're having winter because the sun's rays are indirect, so they're shorter hours of daylight. So, looking at the northern hemisphere only, if we look here, the northern hemisphere is tilted away, so it's winter. But here it's tilted towards the sun, so it's summer. To understand what season these positions are, you have to think, okay, it's winter, then I have a season, then I have summer. So, what season is in between winter and just before summer? So after winter, we have spring and then summer. So in the northern hemisphere, we have winter, spring, summer. This must be autumn, fall. Remember, the southern hemisphere is just the opposite of whatever the northern hemisphere is. Lunar phases.
For centuries, man has been intrigued by the moon's changing face. Sometimes it's high in the sky, some nights it's a sliver, and other times it disappears completely. But this cycle becomes predictable as the moon's phases repeat every month. The Sumerians, Chinese, and Babylonians depended on the moon's cycle to determine their days, months, and years. And the moon's phases still mark the beginnings of Jewish and Muslim holidays. So, what causes the moon to have phases? And why is its cycle consistent? Phases represent the illuminated portion of the moon that we see from Earth. As the moon begins to orbit Earth, the sun's light reflects off the moon, causing a different portion to glow. The moon has four main phases. New, first quarter, full, and last quarter. It takes about 1 week for the moon to change from one of these phases to another. In between, the moon is either a crescent, which means it's less than half full, or gibbous, which is more than half full. When the moon appears to be growing, we say that it is waxing. If it appears to be getting smaller, it is waning. During a full moon, if the moon, earth, and sun align, and the moon passes through the earth's shadow, a lunar eclipse will occur. But since the moon's orbit is inclined about 5 degrees to Earth's, the moon normally passes either above or below the Earth. The best time to observe the moon is during its quarter phases, because the terminator, which is the line that separates light from dark, dramatizes the moon's surface features. You'll be able to see mountains, craters, and scarps in the most contrast and sharpest relief.
So when we look at our 8 phases of the moon, you always want to sniff your moon phases. Start with the sun, the new moon, the earth, and the full moon. It makes a straight line. You want to go counterclockwise as the moon does its revolution around the earth. It takes the moon 1 month to do this. Your major phases are the new moon, first quarter, full moon, and the third quarter or last quarter. In a new moon, you see zero illumination, and then we wax in illumination until we're full. So we get the light on the right hand side of the moon. Once the moon is full, then we wane. We lose that light on the right hand side until we're new again. Crescents always come before and after a new moon. Gibbous shapes come before and after a full moon. It takes 7 days to go from one major phase to the next. Or every 2 moon phases take 7 days. So if I'm a new moon, 1, 2, that takes 7 days. If I'm a first quarter, 1, 2, that takes 7 days, a week. If you're an in between phase, same thing. Every 2 moon phases takes a week. So if I'm a waxing crescent, 1, 2, it will take me a week to become a waxing gibbous. So here's that practice. As I was saying, here are your moon phases, and every 2 moon phases takes about 7 days or a week. Each major phase, new moon, first quarter, full moon, third quarter, lasts only 1 to 2 days. Your in between phases, like your crescents and your gibbuses, are going to last 3 to 5 days. There's a new phase about every 4 days. Spring tides happen in a straight line. That's during a new moon and a full moon phase. This means you have extreme differences between your tidal ranges. You're going to have two very high tides and two very low tides during the day. During a neap tide, which is at a 90-degree angle, that's where you're going to have your least effect between tidal ranges. So again, that's during first quarter and your third quarter moons. You're not really going to have a great difference between your high and low tides because the moon's gravitational pull is pulling in one direction and the sun's gravitational pull is pulling in the other. So if we look at tides, again, a spring tide is a straight line. Neap tides are found at 90-degree angles.
Hey, check out our new test tube app in the iTunes store. Download it, give us a rating, let us know what you think, okay? Okay. Hey there, I'm Josh Clark, and in this Brain Stuff, I explain to you how the tides work. Have you ever seen somebody buried up to their neck in sand on the beach, and then the tide slowly comes in and they drown, and wondered, I wonder how tides work? Well, next time, you'll know, and you can explain it to that person as they wait to die. We need to be very careful here, because as French astronomer Francois Arago once said, studying the tides is the tomb of human curiosity, which means it can break your brain, as you'll see. There's a lot of factors involved in creating the tides here on Earth, but the big three are the moon, the sun, and the Earth. The gravitational pull of all three of those bodies interacting creates the tides. The biggest factor actually is the moon. It exerts about 2.2 times more power on the tides than the sun does. So for once, the moon gets to one-up the sun. It's kind of a big deal to it. Imagine for our purposes the Earth is right here and the moon is directly above it. Now, they exert a gravitational pull on one another, and since on the Earth most things are pinned down, we have shoes, buildings have foundations, stuff stays in place. But the oceans, being literally fluid, actually can be pulled toward the moon, and this is what creates the tide. The moon's here, it's pulling on the ocean at the top of the Earth, creating a high tide on the top. And on the bottom, another high tide is created because the Earth itself is pulled toward the moon, even though the oceans down here have less gravitational pull exerted on them, being farthest away from the moon. So on the top and bottom, you have high tide because of the tidal bulges, and on the sides that are at right angles to the moon, you have low tide because the ocean's stretched thin over the surface of the Earth. Pretty crazy, huh? So, like I said, the sun also exerts an influence on the tides, but it's less pronounced than the moon. See, it actually enhances or diminishes the gravitational pull of the moon here on Earth. When the sun and the moon are in alignment, the sun enhances the moon's gravitational pull, creating higher tides than normal. They're called spring tides, and they happen on a full moon or a new moon. Now, when the sun and the moon are at right angles to one another, with the Earth right about here, the sun diminishes the gravitational pull of the moon on Earth, creating lower than normal high tides, also called neap tides. These happen on the quarter moons. Because the Earth and the moon are constantly moving and moving around one another, there's a constant movement from high tide to low tide. Twice a day, you get a high tide in most places, usually once every 12 hours and 25 minutes. But this can vary, and some places only see a high tide once every 24 hours. Those are called diurnal tides. So this is a daily occurrence, actually twice daily in most places. But tidal waves, even though they have the word tide in them pretty much, but without the E, they're not related to this gravitational push and pull. They're usually the result of earthquakes. So that's tides. Hopefully.
So which picture shows how the moon appears from Earth when it's in the position shown in this model? So if we have the sun here and you're here and you look up at the night sky, this position would be a new moon, but it's showing you your moon's at this position. So you know after a new moon, the moon goes counterclockwise around the Earth and it starts to grow in illumination. It's waxing. So we would be viewing a waxing crescent at this position, correct? So a waxing crescent image, you'd have the light on the right because you gain light on the right as you wax. So letter D.